Okay, everybody, so this is our second lesson on inequalities and interval notation, more specifically compound inequalities. So compound, as the name implies, is more than one at a time. And there are two categories of compound inequalities, conjunctions and disjunctions. Conjunctions typically are presented with the word and, whereas disjunction is with the word or, and it's kind of parallel to what you already know in grammar. So if you and your friend are going to the movie together, that means you're both going. If you or your friend are going to the movie, it means either you are or the friend is, so one or the other. So with a conjunction, both are true at the same time. With a disjunction, one or the other is true. Now, with conjunctions, there's actually two ways to write them. The word and can be present, like x is greater than 5 and x is less than 10. Or the other way to write it is 5 is less than x is less than 10. So these are both equivalent. They mean the same thing. There's just two different ways to say it. Basically, what they're saying is the numbers between 5 and 10. With a disjunction or an or statement, you have to have the word or. There's no other option. There's no alternative way to write it. You cannot link these together like a conjunction if you try. So if you see here, the mouth is eating the 5, and here the mouth is eating the x. So you try to link this together, you come up with something like that. But what that implies is that 5 is greater than 10, and 5 is not greater than 10. So it makes no sense to try to link these together in that way. So an or statement has to have the word or in between the two pieces. All right, so we're going to work through some of these. Some will be fairly simple. I try to say simple and easy at the same time. Fairly simple. Number 2, obviously, like always, I'll do the evens, assign the odds. Number 2 is a conjunction. Maybe I'll jot that down. You don't have to, but just for notes. It's a conjunction, and the goal is to isolate b. So if we want b to be alone, we need to add 4 to cancel that out. Now, when it's written in this form, you just add 4 on both ends. So a normal equation, if you had something like this and you put down a random number, you would add 4 to both sides of the equal sign. Well, there's not both sides of an equal sign. There's inequality here, and there's like 3 sides. There's the left. Oops, that was a dumb choice. There's the left, the right, and the middle. So I add 4 in the middle and the left and the right. This doesn't always work, but most of the time when it's written like this, you can proceed in this way. So you add 4 to the left, right, and the middle, and then proceed in this way, and it just works out to be quicker and easier. So -6 plus 4 is -2. These 4's cancel out. You bring down the b. -2 plus 4 is +2. And this is the answer. You go to graph that. -2 on the number line, we put a dot. Remember, when there's an equal sign, it's a dot. +2, there is no equal sign here, so we're just going to put an open circle. And the b, the variable, is between them. That means all the numbers between them, so you shade in between them. So this should be something you've already learned how to do, you've done before. Like always, it could be something you've forgotten, or maybe you didn't learn it well the first time, or maybe this is perfectly easy, and that'd be great. But we still have to write the answer in interval notation. So in interval notation, what we have is -2 on the left, +2 on the right. The -2 has a equal sign, so there's a bracket. The +2 does not have an equal sign, there's a parenthesis. So that would be the interval notation of the answer. So everything you see there is what I would like you to try to do on these problems. And as usual, I'll scroll down to check myself, because it would be embarrassing to do this all wrong. Yep, so the graph is right, that's right, and then there's the interval notation in my handwriting, because this software doesn't actually do the interval notation. And it looks like my app crashed, so let me try this. All right, I gotta close it down. Ooh, uh-oh, Haskell was playing a game earlier today. Okay, there it is. All right, so there was number 2. Let's look at number 4. This one is also an and, or a conjunction. It's written as 2 separate inequalities, so I'm going to solve them both separately. This one I'm going to subtract 2 on both sides, n is less than 5. This one I'm going to subtract 3 on both sides. You get n is greater than negative 1. Now we want to link these together. We do want to write the final answer in this format here. That's something you're going to have to get accustomed to. So basically, the variable goes in the middle, the smaller number goes on the left, the larger number goes on the right, and then just make sure the mouths eat the right thing. So like this, oops, oh, I didn't mean to do that. Oh, heck. This mouth is eating the 5, and that was a mistake. Let's see. This mouth is eating the n, so there it is right there. To graph it, both negative 1 and positive 5 get circles, no dots, because there's no equal sign. You color in between. To rewrite this in interval notation, negative 1 is on the left, 5 is on the right, parentheses on both ends. So hopefully you can see this is kind of a straightforward, fairly simple process. It kind of helps because I don't have very complicated operations up here, just adding, subtracting, multiplying. They could theoretically get a little more complicated, but I think in this assignment, it doesn't get very much more complicated than this. All right, let me check number 4. I think I just started babbling there. Sorry about that. Okay, so graph is right, answer, inequality notation, or interval notation. Okay, so there were 2 conjunctions in a row, one written in this format where they're linked together, another one written in the AND format where you see they have to be worked out separately. Let's look at number 6. Number 6, hopefully you can see, has an OR in it. So we need to work these out separately. The first inequality over here, to isolate x, we're going to have to cancel out this 8. Since 8 is being divided presently, you must multiply by 8. Multiply and divide are opposites, they cancel out. And multiply the other side by 8, you get x is greater than or equal to 1 times 8 is 8. On the second inequality, to isolate x, we're simply going to have to add 4 to both sides. That cancels out. X is less than or equal to 4. And then you are supposed to bring down the word OR in between. Again, with an or a disjunction, let me write this down, disjunction. In a disjunction, you cannot link them together. So what I'm about to do would be wrong. Put the x in the middle, the smaller number on the left, the bigger number on the right. Make sure the mouths eat the right thing. So this mouth is eating the 4, and this mouth is eating the x. Now this is nonsense because it would be saying that 4 is greater than 8. And 4 is not greater than 8. So you just can't do that. So let's look at the graph. What we do need to do is graph each one of these separately. X is greater than or equal to 8. So I put a dot on the 8 and shade in the greater than direction. That'd be this way. And then for the second one, I put a dot on the 4, and x is less than or equal to 4, shade in the less than direction. That would be this way. So that is what the graph looks like. So we solved each one separately and put OR in between the solutions, and then we graphed them separately. Now for interval notation. Well, for interval notation, let's focus on this arrow first. It goes to negative infinity on the left, and it ends at positive 4. Infinity always gets a parenthesis. This 4 gets a bracket because there's an equal sign. Now let's look at the second arrow. Starts at 8 on the left, and it goes to infinity on the right. 8 has an equal sign, so bracket. Infinity always gets a parenthesis. Now in between these, instead of writing the word OR, I'm trying to think of a way to say this. I don't know. It's just customary. It's just in this particular notation, you don't use the word OR. There's a symbol that represents the word OR. And it's kind of a letter U, sort of, but it doesn't have that stem that a U usually has. So it looks like that. That stands for union. So that U means OR, and it also means union. So we're uniting these two arrows together. The arrows themselves are disjoint. They don't touch each other. Disjunction, disjoint, very similar words. So they don't touch each other, they're separate. So when you put them together to be one answer, you're uniting them or creating a union of the two disjointed arrows. All right, so I got a lot of writing on here. Well, let's scroll down and check and make sure everything's good. So yes, here's my diagram. There's the answer with the word or in between it, and then in my handwriting, the interval notation. All right, let's go for number 8. Number 8. So is this a disjunction or a conjunction? If it's linked together in one long strand like this, it is a conjunction. Now, we can try to solve it as it sits. This is very interesting. So we have our left, right, and middle. And I notice that we have like terms here, here, and here. And they are all the same term. They're all 15x. So when I try to get those together, watch what happens. Oops. So I'm going to have to subtract 15x to get it out of here. But then I have to do the same thing on all sides, left, right, and middle. So that cancels, and I am left with 6 is greater than or equal to 17, which is greater than or equal to negative 16. Okay, like yesterday, if the x completely cancels out of the problem, we have two scenarios. We could have all real numbers or no solution. So this is a special case. Maybe we'll write that down. Special case. People call me a special case. All right, so this is a special case. Is it all real numbers or is it no solution? So you have to look at what you have left and ask yourself, is this a true statement or a false statement? Well, part of it looks like it might be true. For example, 17 is indeed greater than negative 16, but is 6 greater than 17? It is not. Part of this is false, which means the whole thing is false. So this is a no solution. So remember, with no solution, you can write the words no solution, or you can write that symbol. So what is the graph of no solution? The graph of no solution is no graph at all. So really, you can't write interval notation. You can't write an inequality answer because there is no answer. So when we check this, there should be nothing graphed and the words no solution or the symbol for no solution. And there it is. So nothing graphed, no solution, and then the circle with a line through it is the symbol for no solution. So that was number 8. Oh, look, number 7 is also going to be no solution. Okay, what are we up to now? 10. Now, I feel like I'm going too fast. If this were a classroom, I'd slow down, I'd re-explain. You can obviously hit pause. You can back the video up and see what you need. So, keep that stuff in mind. Okay, this one is a disjunction. We're going to solve each inequality separately. So I'm going to start over here on the left, start working with that. And I do believe I'm going to get the variables, the like terms, together. So I'm going to subtract 16p on both sides of the inequality sign, and that's going to give me 1p plus 15 is less than 14. Those cancel out. Now to isolate the variable, I can subtract 15 on both sides. I get p is isolated, less than 14 minus 15 is negative 1. So there's part of my answer. Let's come over here to the other side. Ooh, this is strange. So I need to get these terms together. Minus 4p minus 4p. I get 4 is greater than or equal to negative 19. So the variable completely cancels out. And this can mean, well, this will be tricky. So this is an or statement, but this is probably a special case because when the variable cancels out, it's a special case. When your variable completely cancels out, you have either a true or a false statement. And 4 is greater than 19. That's true. So that means that this portion of it is all real numbers. But this portion is simply, negative 1 with a circle and a graph this way. So, all real numbers, this answer is the whole thing getting shaded. So which is the right answer? The part that's shaded or the whole thing that's shaded? Well, let's check. I believe the answer, I'm not gonna check yet. The answer should be the whole thing is shaded because this sort of overrides that, logically speaking. If I said you could have less than $5 or all the money in the world, you would take all the money in the world, right? I said $5, even though that's a -1, just for an example. So number 10, yep, all real numbers, the whole thing is shaded, and then, of course, that symbol, which is good to know. Oops, too far. Where am I? There we go. Ugh. If anyone gets seasick from me scrolling up and down, type in the comments. All right, so because this is all real numbers, that sort of takes precedence. So let me clean this up a little bit. My graph looks ridiculous. So the whole thing gets shaded, arrowheads on both sides. And this is a special case, all real numbers. You do not need to include that in your answer. If you wanted to, you could do the -infinity to +infinity. That would be an option as a way to write your answer. Okay, number 11. This is another conjunction. So we've got the inequalities linked together in a strand like this. Now, if we try to work on it like this, it's actually not going to work out very well. So let me start this, show you why it's a bad idea, then I'm going to erase it and do it the right way. So we want our variable to be consolidated in the center. So I'm going to have to subtract 10p here to cancel that out, right? But then I'm also going to have to subtract it here and here, because like an equation where you do the same thing on both sides, this type of inequality, you have to do the same thing in all three places, left, right, and middle. So I get -20 is less than -2p plus 8, which is less than -3p minus 3. But see, I still have a p over here. I will need the variables consolidated in the center, which, oops, let me fix that. Which then you would say, okay, you just add 3p to cancel this out. So you add 3p. But you also have to add it here, which then gives you 3p minus 20 is less than p plus 8, less than or equal to -3. And it's still not consolidated. We've got it here. So you would have to subtract 3p here. And now we're just going in circles. This is going to take us back up to that answer. So there's no way to really do that. So like I said, this whole thing, this whole method here is wrong. This is one of the instances where kind of working this out as you see it, it fails. Up here, it kind of worked because we had 15x in all three locations and they all canceled out. Up here, where is it? Up here it worked, no, not there. Right here it worked because there already was just b consolidated in the center. You didn't have variables on both ends. So that was easy to work out. But for this one, having the different variables in the left, right, and center kind of messes it up. So unfortunately, our only option is to work them out as two separate inequalities. So write the word and then duplicate this center part. So let me show via highlighter. These went together here. I wrote the word and then change colors up. These go together here. And you solve both of those. So I'll go ahead and work this out. I'm going to subtract 8p. 2p minus 20 is less than +8. Add 20 to both sides. 2p is less than 28. Divide by 2. P is less than 14. I'll work this other one out. Subtract 7p. P plus 8 is less than or equal to -3. Subtract 8. P is less than or equal to -11. Oops, OP, what? This is an AND problem. So I do this. Now I need to link them together. So how do now, you can link AND problems together. You just cannot link OR problems. How does that work? You put the variable in the center, smaller number on the left, larger number on the right, and then look at the mouths. This mouth is eating the -11. This mouth is eating the 14. Now think about that for a second. Does that make sense? Okay, is that enough time to think about it? This does not really make sense. That would be saying that negative 11 is greater than 14. So that is kind of a problem. Does that mean this is a no solution? Not necessarily. No solutions come up. It can come up in a situation like this, but usually it's where the variable completely disappears. So what I'm going to do is I'm going to graph both of these and try to interpret the results that way. So this says p is less than 4. 14. 14 would be way the heck over here, an open circle, and shading this way. And notice the number line doesn't even go that far. So that maybe tells us something is fishy also. P is less than negative 11 starts here, less than or equal to, so it's going to be a dot and shade this way. In fact, you know what I'm going to do? I'm going to do that in a different color. Let me do this one in sort of the light blue. So a dot here and shade this way. So now we need to talk about the word and what it means in math. And means that both things are true. Is it possible for a number to be less than 14 and less than negative 11? It is possible. Think of a number like negative 100. It is less than both of those. If you think of another number like 5, 5 is less than 14, but it's not less than negative 11. So with an and, we're only basically allowed to count the answers where both are true at the same time. That goes back up to these notes. With and, both have to be true at the same time. So what that means is the answer can only be the numbers represented by the light blue arrow. The light blue arrow covers a section of the dark blue arrow. Therefore, that's physically where they're both true, which means we have to kind of disregard this part of the answer. So I'm going to erase that, and that's why it wasn't even on the number line. Of the two answers, this one, oops, I meant to highlight that. This one is only the one where both of the and parts is true. So our answer is simply p is less than negative 11. We don't need to put and in our answer. The arrow looks like what you see up there. I've done it in two colors now. And the interval, well, let's see, the left is negative infinity. The right is negative 11. Infinity always gets a parenthesis. Negative 11 gets a bracket because of that equal sign right there. So let's go down and check number 12 now. And there it is. So the arrow is just this part, that, and that. So that was an especially tricky problem. I'm not going to sugarcoat it. It was interesting. All right, let's look at number 14, and we'll be just about done. This one's already split up as an and problem. Let's see. The first part I'll solve by subtracting 2 to get my variables together. Negative 3 is greater than 2 plus x. Subtract 2 over to here, and I get negative 5 is greater than x. Work this other one out. I'll go ahead and add 4x to both sides. 10 is greater than 10 plus 2x. Subtract 10 on both sides. 0 is greater than 2x. Divide by 2. 0 is greater than x. And then in between here, we're supposed to have the word and. Let's see if we can link this together. Okay, so x is in the middle. Smaller number on the left. Larger number, 0 is larger than a negative number, on the right. And kind of like before, we've got these mouths going in two different directions. So that sort of implies that 5 is greater than 0, which means something is up. It's not necessarily no solution because the variable didn't completely disappear, but it could be. But more likely, this is like number 12, where the two arrows end up overlapping each other. So let's check. If I graph this one, another way to look at it is like this. So you can flip it all around if it's easier to view that way. So negative 5 gets a circle, and then x is less than that. That goes in this direction. And then 0 is greater than x. Another way of looking at that is x is less than 0. So that would be a circle over here. Let me do that in a different color. No, different color. So -1, 1, 0 would be right here. That'd be a circle and going this way. And again, and is a region where both are true. So where do these two arrows overlap? They only overlap right here, which means this portion of the answer is the answer. This is, maybe we could call it extraneous. It's extra information that isn't really part of the solution. So our graph is only going to be that arrow. And to write it in interval notation, negative infinity on the left, -5 on the right with a parenthesis. That should be it. Let's look. And there we see that's how it all is. So there are some tricky conjunctions where it doesn't work out to be like, let's say like this, where you can just string them together and it makes sense. It doesn't work out to be like this, where stuff all cancels, the variable disappears, and it's a no solution. It sort of works out so that of your two arrows, only one of them gets counted as your final answer, and that's the one where the two arrows overlap each other. Okay, I think I should call it an end, put an end to this because I'm going on and on and on. Please try the odds, show your work, check yourself. The answers are down below. Do your best, and of course, contact me through the normal means if you have any questions.